we'll start with the root locus technique. So if you see in the previous class, we have used route stability analysis. In the route stability analysis, you will know whether a particular system is stable, unstable, or limitedly stable. Only this much information is available in route stability criteria. The problem with that is once you design the system, and if the system in analysis, if it turns out to be unstable, it is not possible to discard that system and start with fresh. So there you have to do a further analysis to find out why a particular system is stable or unstable. If the reason for instability, if that is corrected, then that particular system completely becomes useful. So by getting the answer yes or no type, that is in the route stability criteria, you will get whether the system is stable or unstable. But why a particular system is stable and why a particular system is unstable, that you will not come to. That means you will not have much details. At the same time, once a particular system is stable, suppose, that is not the end of the analysis. Reason is the stability here has to be associated with the performance of the system. For example, if you take a spring mass damper system that is in your suspension, after analysis, if you find out that particular system is stable, generally second order systems are always stable, most of the cases. And your spring mass damper system is generally considered as a second order system. Now, that is not the end of the story because you require a particular level of comfort while driving your vehicle. Only stability is one part. The other performance characteristics are different part. So this detailed analysis you can't come to know. See, suppose your spring mass damper system is highly overdamped, then practically it is useless. Even though it is stable, it is useless basically because all the shocks what the shock observer is supposed to absorb are simply being transmitted to a rider. So that will not be, a journey will not be comfortable at all. Similarly, if the damping ratio is very low, in that case, even though most of the shocks are absorbed, but the ride will be oscillatory ride. That means once again, it will not be a comfortable one. So depending on the application of a particular system, you have to just getting the stability is not enough, but detailed analysis has to be carried out. And at the same time, what are the parameters affecting the performance of the system and how those parameters can be fine-tuned, how those parameters can be tuned to get a very good quality output as per the requirement of your design. So for that analysis, the route stability analysis will not be only sufficient. So for most of the other design considerations, this root locus plots or root locus technique in general in time response analysis is employed. So what is meant by root locus plot? The root locus plot is plotted on real and imaginary plane or in S plane, that is sigma and j omega axis, to see the movement of the roots if a particular parameter is changed. That means a parameter here is generally associated with the gain of the system K. If the gain of the system is changed, how the performance of the system changes. This analysis will come to, you will come to know. So here if you see that a performance gain, if the gain of the system is varied from 0 to infinity, for example, whether a particular system remains stable throughout, that is one thing, and how its response will go on changing. That means depending on the position of the roots, you will come to know whether the response is oscillatory response or a non-oscillatory response. Oscillatory response is associated with underdamped system, whereas non-oscillatory response is associated with overdamped system. So whether you want a particular system to be overdamped, suppose you are designing a spring mass system, can be used for a door closer also, as well as for vehicle suspension also. For vehicle suspension, it has to be underdamped, and damping should be tuned such that the ride should be comfortable, and at the same time it should not be highly oscillatory. Whereas in door closer, the system has to be always overdamped. Overdamped means how much overdamped? That is also important. If if the system is very highly overdamped, then the door will not close itself. So it will remain open. Whereas if the damping ratio is very less, in that case, door comes and ramps the frame. That means very purpose of using the door closer is lost. So that's why complete analysis has to be carried out. So from the route stability criteria, you will just know whether a system is stable, unstable, or limitedly stable. After that, this is a higher analysis that has to be performed for the design of a control system. Then here, the general rules of the construction of the root locus has to be discussed. There are, in general, 8 rules are there. Before coming to that, we'll see how the roots of a particular simple system will vary if the gain of the system is changed. So for that, suppose we'll take, see here, generally up to second order system only complete detailed analysis can be done, basically because second order roots can be found out very easily by using the formula b square minus 4ac formula that you are familiar with. So that's why we take one simple, a second order system. A second order system open loop transfer function g of s with a unity feedback, that means h of s is 1, is shown here. That is k divided by s into s plus a. That means here if you see the open loop transfer function is k divided by s plus s into s plus a. So in the previous class you might have seen we go across what is known as pole and zero concept. If you go about pole and zero concept, the pole is one which makes the transfer function infinity, and pole zero is one. At that value, the system transfer function becomes 0. So the poles are always in the denominator, and because if in denominator becomes 0, the whole transfer function will become infinity, and zeros are always in the numerator, because if those become 0, then the transfer function becomes 0. Now, if the open loop transfer function is k divided by s into s plus a, that means in the numerator only k is there, that is constant. That means there is no 0 in the numerator. There is no s value which will make the transfer function 0. So there is no 0 here. So number of zeros are 0. Whereas in the denominator, s is equal to 0 if you put s is equal to 0, this transfer function becomes infinity. So that means there is one pole at s is equal to 0. Then similarly, if you put s is equal to minus a, then this s plus a terms becomes 0. And because of that, the transfer function becomes infinity. So there is another pole at s plus a. The s plus a is equal to 0. That is s is equal to minus a. So there are 2 poles and no zeros in this particular system. You have to see the open loop transfer function only to start with. But in this particular problem, we'll do without the root locus technique. Normal method, how to do it. That is possible only for the small systems, not for higher order systems, because it is physically not possible to go on calculating the roots at different values of k. Now, here the closed loop transfer function g of s divided by 1 plus g of s h of s, if you do, you will get the transfer function. Here g of s is k divided by s into s plus a, whereas h of s is 1. So g is same, divided by 1 plus this plus 1 into 1. And if you simplify that, then it will become k divided by s square plus 2as plus k. That means it is a second order system because highest power of s is 2. If you take the characteristic equation of the system, that is the denominator of the transfer function, closed loop transfer function. This is open loop transfer function. This is closed loop transfer function. If we take the denominator of closed loop transfer function and equate it to 0, that is called as characteristic equation that you are very much familiar in Raoult stability criteria. So that I will equate it to 0. That means s square plus as plus k is equal to 0. That means it is a second order equation. So it will have two roots, s1 and s2, which is equal to minus a and minus b, that is minus a, plus or minus under root of b square, that is a square, minus 4ac, that is 4 into k, divided by 2a, that is 2. So whole thing when you divide it by 2, then a divided by 2 is the outside term, then plus or minus under root of this 4 I can take common, so it will get divided by 2 here, so that outside 2 and this inside 2 will get cancelled. So it will become a by 2 whole square minus k. Now I am going to change the value of k. Now I will change the value of k. If I put k is equal to 0, if I put k is equal to 0, what will happen? Just see. If I put k is equal to 0, that is the starting point of our root locus normally. So k, if you put equal to 0, this becomes a by 2 whole square under root, that is a by 2 only. So a by minus a by 2 plus a by 2 will vanish because it will become 0, and minus a by 2 minus a by 2, it will become minus a. So the two values will be 0 and minus a, correct? So that is plotted here. So when initially when k is 0, one point is here, that is at 0, another point is here at a, that is minus a. Minus a, remember, this is our j omega axis, this is our sigma axis. So here we have to plot the real parts, and here you have to plot the imaginary parts. It is in Cartesian coordinate system. So the starting point of the root locus when k is equal to 0, one point is here, one point is here. You can see here properly. So k is equal to 0 is written. K is equal to 0 is written. That is the starting point. Okay. K is equal to 0. K is equal to 0. Okay. So in between the that will come later. Then next value I will put equal to k something which is, suppose now the next value, if the now k is greater than 0, it goes on increasing. When k is greater than 0, this negative quantity goes on increasing. When the negative quantity goes on increasing, this under root quantity goes on decreasing. If this under root quantity goes on decreasing, suppose k is equal to a by 2 whole square. If k is equal to a by 2 whole square, under root quantity becomes 0. So under root quantity becomes 0 means, that means this under root part will become 0. The two roots will be at minus a by 2 only. So as k goes on increasing, when k is equal to a by 2 whole square or a square by 4, in that case, this point and this point both will come towards that and will meet here. Is it clear? As the k value goes on increasing, this root, if you see, which is when k is equal to 0, as k value goes on increasing, this root will start moving towards left. Whereas this root, which was here at a minus a, it will start moving towards right. And when k is equal to a by 2 whole square, that is a square by 4, they will meet each other. When they meet each other, afterwards what will happen? Just see. That means if the k by 2 k becomes greater than a by 2 whole square, this under root quantity becomes negative. When the under root quantity becomes negative, root of a negative quantity is imaginary. So then what happens is, as k goes on increasing further, more than a by 2 whole square, there will be a real part which is equal to minus a by 2, and there will be imaginary part which is j times something. So that means if you start increasing the k is equal to a by 2 whole square, after meeting here, one root will start moving upwards because its imaginary quantity will be positive, but the real part will be same, always minus a by 2 only. Whereas another root will start moving downwards because its imaginary part will be negative. So that means if you see the root locus, this is a root locus. So now this k can be infinity. You have to go on increasing k up to infinity. Whatever may be the value of k, the real part will be always minus a by 2 only. But the imaginary part will go on increasing in one in this direction, one in this direction. That means there are two lines here or two root locuses. One starting here, it will come here and meet here. Whereas another one starting here, as k value goes on increasing, it will slowly move on the real axis and meet at minus a by 2. Once they meet, one root locus will go upwards, that is parallel to j omega axis upwards, and one root locus will go downwards parallel to j omega axis, because both roots will have same real part minus a by 2, but the imaginary part j value goes on increasing along with the k value. Is it clear? So this is nothing but the root locus. So from this, what you can analyze? You can see this system. The roots are continuously visible to you now. Whatever value may be the k, you will come to know what is the position of the roots. So here, when k is equal to 0, one root is on at origin and another root at minus a. That means what about the stability of this system? This system is limitedly stable. Why? Because there is a presence of root on the j omega axis. There is one root on the j omega axis and second root on the left hand side of the j omega axis. That left hand side makes the system stable, but another root which is at the origin at present, it makes the system neither stable nor unstable because it is not on the right, it is on the line on j omega axis. Hence the system is limitedly stable. As the value of k goes on increasing, greater than 0 but less than a by 2 whole square, these roots will move along the real axis only. This root will start moving slowly towards this. This root will start moving slowly towards this point. That means the roots will be on the real axis. When the roots are on the real axis, that means the performance of the system is non-oscillatory. It is overdamped system. It is a overdamped system because the oscillations will not be there. One straight line curve will be there. So the straight line is, this curve may be straight line also. So as long as k value is a by 2 whole square, the roots will be on the real axis and hence the performance of the system is overdamped. When they will meet each other, when k is equal to a by 2 whole square. At that time, both the roots are at the same spot. When both the roots are at the same spot, that is a clear indication of critically damped condition. That means zeta value or damping ratio of the system is 1. So they meet each other. You compare this with your standard second order plot, which we have done in time response analysis. So that becomes critically damped. But if the value of k increases beyond a by 2 whole square, the roots will start moving in the imaginary plane. It will start moving in the imaginary plane with the real part minus a by 2 and imaginary part goes on increasing along with the k. And hence the performance of the system, even though it is stable system because all the roots are on the left hand side. When all the roots except value of k is equal to 0, the system is always stable only. because all the roots on the both the roots are on the left hand side only. So naturally the system is stable except the value of k is equal to 0. But afterwards, if the value of k is less than a by 2 whole square, the system is overdamped. When is equal to a by 2 whole square, it is critically damped. And if it is greater than a by 2 whole square, it is underdamped. So not only you will come to know the stability of the system, you will come to know the performance of the system, that is whether it is overdamped, whether it is critically damped, or it is whether it is underdamped. All this additional information you will come to know. So that means from that you can design the system also, because in the design you have to select properly the value of k. So that if you intend to make this system overdamped, then choose the value of k below a by 2 whole square. If you want to make the system critically damped, then choose the value equal to a by 2 whole square. And if you want to make the system underdamped, then you choose the value greater than a by 2 whole square. And how much underdamped? That means underdamped system means the zeta value will go on decreasing as the value of k goes on increasing. So you have to choose the k value or gain of the system, and depending on your requirement of the damping. So if the second order system, you can design a door closer also or suspension system also. For door closer, you have to use overdamped system. That means you have to choose the value of k below a by 2 whole square. And critically damped, very rarely it is being used. And if you want to make it as a suspension system for a car or a two-wheeler, then choose the value of k such that it is greater than a by 2 whole square. So and the oscillations will go on increasing as the value of k goes on increasing. So you have to optimize that, and so that it will not be too much oscillatory or too much rigid. This is how the root locus is helpful to you in construction, in understanding not only the stability of the system, but the performance of the system. Now, as this system was very simple, I could go on finding out the position of the roots at different value of k. I have joined those values of, I went on increasing the value of k from 0 to a by 2, and those points I have joined. That is root locus. It is called as joining of the 2 point is called as locus. Locus of the point means what? You have to join all the points in that group. So one root locus I went on joining like from here to here, and another root locus I went on joining from here to here. Afterwards, one root locus I have joined all the points by increasing the value of k, and like this. Only crucial points are discussed here. It is not necessary to put all the values of k here. You can get them very easily and you can plot them. So complete root locus can be plotted like this. But this can be done only for simple systems which we have discussed so far. If the system is third order system, fourth order system, finding out the root once only is difficult, and changing the value of k every time finding out the roots are not possible at all, even for the computer also. So for that purpose, what we do, there is one approximate method of drawing the root locus. There is one approximate method. See, root locus plots are always approximate only. Nowadays, you can get the real root locus plot by using a MATLAB solution. So, ready programs are available for construction of a root locus by using a MATLAB. And if you buy the books like Who or Raven, along with that, the MATLAB solved CD is also available. So you can run that CD and see how the root locus is plotted by the computer. But that is possible now. But when this techniques was developed, that is way before the computer was invented, or computer were very expensive. That time we used to do it by manually, and manual means it is an approximate method only. It is only a illustrative method, just to visualize for a design engineer how the performance of the system is. It is just for visualization purpose, and further, once he concentrates on the area of his interest, only that part he can calculate and get the answer. Not whole root locus has to be plotted. Now, There are 8 rules for construction of the root locus. This is approximate method of drawing the plot, just like the previous plot. It is an approximate method. So for that purpose, I will discuss those 8 rules. See, these 8 rules are not like a Bible. See, they book to book, these rules number will vary, but the gist is same. So in some books you will find 10 rules. In some books there are 8 rules. In some books there are only 6 rules. That means some of the rules are clubbed together to make it small, less number, or expanded further to get the more number. So in general, in Nagarat Gopal and all most of the books there are 8 rules. So that's why I am following the 8 rules, and the order of the rules are also not same. So for my convenience, whatever I felt better, I have made those as per as my order. So the order may vary from book to book. Remember that thing. For that purpose, to construction of the root locus, you have to be given with the open loop transfer function. You have to start your job once you know the open loop transfer function, and that once that open loop transfer function also should be in a factored way. In a factored way. See, it should not be given in the expanded way. That means it should not be given like that is this. If you multiply s plus 1 and s plus 2, it will become s square plus 3s plus 2, and then it becomes s cube plus 3s square plus 2s plus 2. It will become like that, and that it should not be given in that form, but it is in the factored form, so that you can easily find out the poles and zeros. And in the numerator you have a k here. So the open loop, first thing is, the first rule says that root locus starts at open loop poles. Root locus starts at open loop poles when that time k is 0. Root locus always starts at open loop poles when k is equal to 0. The open loop poles are, in this problem you can see the open loop poles is one pole at s is equal to 0, one pole at minus a. So it started here when k is equal to 0. One at 0, one at minus a. Similarly, the rule says that root locus always starts at open loop poles when k is equal to 0. So what are open loop poles? In our problem here, there are 3 open loop poles. You can see one at s is equal to 0, one at s is equal to minus 1. That means you have to put this bracket equal to 0. S plus 1 is equal to 0 means what? S is equal to minus 1. Similarly, if you put this bracket also equal to 0, that is s plus 2 is equal to 0 means s is equal to minus 2. So there are 3 poles. S is equal to 0, s is equal to minus 1, s is equal to minus 2. And we'll represent the number of poles as capital P, which is 3 in number. That is, I have written, and I have plotted those poles on sigma and j omega axis, and one pole is at origin. Poles are always represented by a cross marks, and zeros are represented by O mark or a 0 mark. So here one cross is there, another cross I have put at minus 1, another cross I have put at minus 2. These are the first rule. Second rule is root locus ends at open loop zeros. Root locus will end at open loop zeros. That time the value of k is infinity. So see the numerator. Zeros are available in the numerator, poles are available in the denominator. So in the numerator there is no s term is there. So there are no zeros. When there are no zeros, that doesn't mean, that is number of zeros capital Z is 0. That doesn't mean the root locus never ends at all. See, whatever starts has to end somewhere. So it will end then at minus infinity. It will always end at minus infinity. Minus infinity can be anywhere in this left hand plane. It can be along this axis, along this axis, along this axis. Anywhere it will go. It will go anywhere. So it will be there on the left hand side of the S plane. Anywhere. Minus infinity. So that means there exists always one zero, imaginary zero at a minus infinity. Minus infinity can be anywhere. Infinity means infinity, and infinity can be anywhere, but it is on the minus side. Why minus side? Because that is a rule. So this is the second rule. Then you have to calculate what is number of root locuses. How many root locuses are there? So in the previous problem you have seen there are two root locuses, one starting here, one starting here, and there are two ending also. One which starts has to end. So there are two root locuses, one starting here and one starting here. They meet each other, one going this way, one going this way. So similarly here, if you see, there are how many root locuses will be there? As per the rule number 3, the number of root locuses n, capital N, will be equal to number of zeros, or if number of zeros are greater than number of poles, or equal to number of poles if the number of poles are greater than number of zeros, or equal to 0 or pole if both are same. Now in our problem there are 3 poles are there and 0 zeros are there. So the number of root locuses will be equal to number of poles, because number of poles are greater than number of zeros. So number of poles will be 3, hence the number of root locuses n will be also equal to 3. This is the third important point. Then the next important point, rule number 4, number of asymptotes. See, in root locuses we are going to get the curves. Plotting the curve is always difficult, and here we are doing a approximate method. How we draw the curve is not important. When we want to represent the curve, the best way of approximately representing the curve is drawing the asymptote to that. What is meant by asymptote? Asymptote is a tangent which is supposed to meet that curve at infinity. Asymptote is tangent drawn to the curve which meets the curve at infinity, means never meets. It never meets. So first one is number of asymptotes. Once again, the number of asymptotes will be equal to number of poles or number of zeros, whichever is higher. So it is same as capital N only. So the small n is the number of asymptotes which will be equal to capital N, and that will be equal to 3 in our case. Then these asymptotes, to draw these asymptotes are straight lines. So to draw a straight line, one method is to know the 2 coordinates of the straight line, and another method is know the starting point of the line and know the angle of that line. So we'll find the starting point and angle. So first, to find out the angle of those straight lines, there are 3 straight lines now, or 3 asymptotes now. So 3 angles can be calculated by the formula given here, 2q plus 1 into 180 degrees divided by number of poles minus number of zeros. This is a mod of this. Mod means sometimes number of zeros are more than number of poles. In that case, this will be negative. So angle cannot be negative. Angle is always positive only. So you have to take the denominator mod of that. That means you have to just take the difference between P and Z, not the sign. You should take only the difference, not the sign. So here Q can take value equal to 0, 1, 2, so on up to P minus Z minus 1. P minus Z minus 1. So in our case, it will take only 3 values. What are the 3 values? It will take 0, it will take 1, it will take 2. Why 2? Because P minus Z minus 1 is, P is 3, Z is 0, minus 1. So P 3 minus 0 minus 1 is 2. So highest value of Q is 2. So it will have 3 values, 0, 1 and 2. So first you put Q is equal to 0 in this equation. If you put Q is equal to 0 in this equation, 2 into 0 plus 1, that is 1. 1 into 180, that is 180. 180 divided by P minus Z, that is 3. So 180 divided by 3 is 60 degrees. Then second value of Q is 1. If I put Q is equal to 1 here, Q into 2 into 1 is 2 plus 1, that is 3. 3 into 180 divided by 3 is 180 only. And the third value of Q, the last value, that is 2. So 2 into 2 is 4. 4 plus 1 is 5. 5 into 180 divided by 3 is 300. So the three angles you will get as 0, 180, 60. And angle is always measured in a counterclockwise direction to the positive real axis. This is our positive real axis. Angle is always measured in a counterclockwise direction. If you measure the angle in counterclockwise direction, it is positive. If you measure the angle in clockwise direction, it is negative. This is the commonly used convention. It is commonly used convention, and hence, so first angle I have plotted as 60 degrees. Second angle I have plotted as 180 degrees. Third angle I have plotted as 300 degrees. So 300 degrees also can be written as minus 60 degrees. See, this is minus 60. Because if I measure this angle in a clockwise direction, it will be negative. So 360 is the total. If you want to measure plus 300 degree means it is minus 60 degrees. Then starting point of these asymptotes, I have shown it to some point where that point lies. That is called as centroid of asymptote, and this centroid of asymptote is always on the real axis. It is always on the real axis. When it is always on the real axis, that means x-axis. When it is always on the x-axis means it will have only x coordinate, no y coordinate. Because if the point lies on the x-axis, its y coordinate is 0. That is common sense. So it is given by sum of real part of the poles minus sum of real parts of the zeros divided by number of poles minus number of zeros. This is the formula. Once again, in the denominator, you have to take only difference, not sign. If the z is more than p, that means not minus. It is plus only because you have to take mod of that. So I will put the real part of the poles. One real part is 0. One real part is minus 1. One real part is minus 2. So 0, I have to add that. Algebraically add that. 0, minus 1, minus 2. So it will become minus 3. There are no zeros in our problem. So 0, sum of their zeros is 0. So minus 1, minus 2, that is minus 3, minus 0 is minus 3 divided by 3 is minus 1. So the centroid, that is starting point of these asymptotes, will be at minus 1. This point is minus 1. Minus 1 means it is on the left hand side of the j omega axis. This is rule number 4. See, this rule can be split into 3 different rules. One, angle of asymptotes, number of asymptotes, and centroid of asymptotes. In some books, these are grouped under 3 different rules. Rule number 4, number of asymptotes. Rule number 5, centroid of asymptote. Rule number 6, angle of asymptote. This way you can increase the number, but as everything is related to asymptote, I have grouped it into one category only, that is rule number 4, which will calculate 3 things, that is starting point of the asymptote, that is centroid, which is always represented as sigma A. This is Nagarath and Gopal terminology. Book to book, it will vary. It may be, I can say it as C also. C as a centroid of asymptote, which is minus 1. Then the number of asymptotes are 3, that is equal to same as number of root locuses. And then the angle of asymptotes are 60, 180, 300. Here also no calculation is required. Basically, just see, you can remember these angles. If P minus, it depends upon P minus Z. If P minus Z is 1, if P minus Z is 1, that means we have only one asymptote. And that asymptote value is 180 degrees only. If the P minus Z is 2, if P minus Z is 2, there will be 2 asymptotes, one at 90, one at 270. You can calculate also. You can calculate also. Then if P minus Z is 3, our case, here the angles are 60, 180, 300. If P minus Z is 4, then the angle will be 45, 135, 225 and 315. That means they are 45 degrees apart. Like that, that means this is fixed. You need not have to calculate. You can remember this. And you will, if you solve 2 3 problems, you will become familiar with that. Otherwise, you have this formula, you can calculate. Rule number 5. Rule number 5 says that root locus is always symmetrical about real axis. This is our real axis, correct? This is our real axis. It is symmetrical about that. So whatever is above this, same thing will be below this. That means real axis is like a mirror. It is like a plane mirror. So whatever you see above that, same thing you will see in the image. So it is always about real axis only, not imaginary axis. Don't get confused. It is not symmetrical about y-axis. It is symmetrical about x-axis, that is our real axis. And the root locus on the real axis lies when there is poles on the real axis, or poles or zeros on the real axis exist. Then the root locus will lie on the real axis. Okay, fine. Then next one is what is known as a breakaway point or break-in point. Breakaway lies between two poles, two consecutive poles. If there are consecutive poles are there, then consecutive means two continuous poles are there, then breakaway point lies. And break-in point lies between two consecutive zeros. If there are two consecutive side by side zeros are there. So what is physical meaning of this breakaway point? Look this. We'll go to that our previous problem. As the value of k has been increased, root locus starts at open loop poles when k value is 0. As the value of k increases, these two are approaching each other. This is not going this way. This is not going this way. They are trying to approach each other. And when they approach each other, they meet here. The meeting point of two root locuses is either called as breakaway point or break-in point, depending on whether it is between the poles or between the zeros. If it is between the poles, it is called as breakaway point, because see the arrow mark. See the arrow mark. Root locus arrow has to be shown. So as the value of coke goes on increasing, this root will go towards left. So the arrow is towards left. Whereas root locus starting here, arrow is towards right. And when they meet each other, they break away. They go away from the both the poles. That's why it is called as breakaway point. So a by 2 minus a by 2 is breakaway point here. I want to find it in our problem. So how to find out the breakaway point in our problem? That is the rule here. For that purpose, here in our problem, there is no zero. When there is no zero, that means there is no break-in point. Only breakaway points will be there. So how to find out that breakaway point? For that, first find out the characteristic equation. The characteristic equation is 1 plus g of s h of s equal to 0. That you have done it in Raoult stability criteria. I will do that. 1 plus, this is g of s. H of s is 1. So I have not considered h here. So 1 plus g of s only I have considered, and that I have equated to 0. So if you take this as LCM, it will come here. And when you take this LCM this side, it will get multiplied by 0. So it will become 0. So then it will become s into s plus 1 into s plus 2 plus k is equal to 0. So that means if you expand this, s into bracket s square s plus 1 into s plus 2 is s square plus 3s plus 2 plus k is equal to 0. I will arrange in decreasing order of s. So that is s cube, then 3s square plus 2s plus k is equal to 0. This is our characteristic equation. Then see what happens is breakaway point means, see here, it is the point where the value of k is maximum on the real axis. Correct? As the value of k goes on increasing, this starts moving this way and this starts moving this way. And when they meet, afterwards, the root locus never stays on the real axis. It will move to imaginary plane, one towards top, one towards bottom. Hence, I want to find this point means I have to find out the maximum value of k. When I find out the maximum value of k, that corresponds to this point. So how to find out the maximum value or a minimum value? You have to differentiate k with respect to s and equate it to 0. If you differentiate dk by ds equal to 0, it will give you the maximum or minimum value as per the maximum minimum principle what you have studied in mathematics. If you want to find out maximum or minimum value of any equation, you simply differentiate that equation with that variable and equate it to 0. You will get two values. One will be maximum, one will be minimum. Okay. So I will take this equation. I will find out the value of k. K will be minus into bracket s cube plus 3s square plus 2s. Then I will differentiate that dk by ds and equate it to 0. If I differentiate with respect to s, s cube becomes 3s square. 3s square becomes 6s and 2s becomes 2, and that is equated to 0. So the minus sign doesn't have any meaning because it is 0 only. So that means the equation becomes 3s square plus 6s plus 2 is equal to 0. If you find out the roots of this equation, minus b, that is minus 6, plus or minus under root of b square, that is 36, minus 4ac, that is 4 into 2, that is 4 into 2 into 3, that is 24, divided by 2a, that is 6, 3 into 2, that is 6. Okay. That's why it will become, if you simplify that, minus 6, this is 36 minus 24 is 12, root of 12 you will get. Once you have to add that, once you have to subtract that, divide it by 6. One point will be minus 0.423, another point will be minus 157. So I don't know which is maximum, which is minimum value of k. One is maximum, one is minimum. Now, coming back to the next point. Coming back to the next point. So remember these points. See, calculation is, even a school student also can do the calculation, but interpretation of the result is the most important part. And that interpretation of the result, I cannot teach you. You have to learn on your own by your experience. I will give you the hints. If I do 2-3 problems, you will only try to understand that. And at the same time, wide varieties of problems are available on this particular topic. If you take some 3 books, you will not get less than 100 problems on the variety of the problems. So that is not the criteria, but you can interpret that, and that requires the practice. So just calculate this and leave it here. Don't bother much about that. So the meeting point of two root locuses is either this way or this one. I don't know at this stage. Then next rule, rule number 7. Intersection of the root locus with the imaginary axis. Where the root locus, whether it will cut the imaginary axis or not, I want to find out. Imaginary axis is y-axis. I want to see whether it cuts the imaginary axis. In this particular problem, it never cuts the imaginary axis. It will go always parallel to the imaginary axis. So there is no intersection of the root locus with the imaginary axis here. But in our case, it is there because I know the solution. That's why I can tell like that. But that you have to find. So to find that, what I have to do is, I have to use the route stability criteria, which you have done in the previous chapter. I will take the characteristic equation. This is the characteristic equation we have taken just now. Take it further. Q of s equated to 0, s cube plus 3s square plus 3s plus k. I will arrange the routes array. S cube, s square, s1, s to the power 0 term. S cube term, coefficient of s cube is 1. Leave this, coefficient of s is 2. Whereas second row, s square terms, coefficient of s square is 3. Leave this, coefficient of s to the power 0 is k. Then simplify this, 3 into 2, 6 minus k divided by 3. Then next term, there is no term here, so 0 only. Next, you move further. 6 minus k divided by 3 into k minus 0 divided by this is k itself. So the root locus, now the system to be stable, you know, all these first column elements should be positive. Or now, if this term becomes equal to 0, if this term becomes, k should be greater than 0 first. K is equal to 0, root locus is on the imaginary axis only. Why? It is the starting point. So the starting point is on the imaginary axis only. When k is equal to 0, one of the roots is on the imaginary axis. So that's why when k is equal to 0, it is also on the imaginary axis. So that is not the, here you will get that idea. When k becomes equal to 0, it will cut the imaginary axis. That is one point. Second point is when 6 minus k divided by 3 equal to 0. 6 minus k divided by 3 equal to 0. That means k is equal to 6. When k is equal to 6, the root locus will cut the imaginary axis. When k is equal to 6, the root locus will cut the imaginary axis. Put that value of k here back into this equation. If you put k is equal to 6, 6 minus 6 is 0. That means this whole row has become 0. This whole row has become 0. When the whole row becomes 0, you will get the auxiliary equation, that is difficulty number 2 in the route stability criteria. Correct? In the yesterday's class, when whole row becomes 0, you have to take the auxiliary equation, that is what is being told to you. Now write down the auxiliary equation. This corresponds to a square term. This corresponds to s to the power 0 term. That means this is 3s square. Now row preceding to that is auxiliary equation. This is the row has become 0 now when k is equal to 6. Now this row corresponds to the auxiliary equation, that is 3s square plus k is equal to 0. That means I will put the value of k as 6. That is 3s square plus 6 is equal to 0. I can take 3 common. That means s square plus 2 is equal to 0. I will divide this equation by 3. So it will become s square plus 2 is equal to 0. That means s square is equal to minus 2. And that is equal to s is equal to minus 2 under root is j. J term will come because it is imaginary. So plus or minus root 2j. So when k is equal to 6, the root locus cuts the imaginary axis at s is equal to plus root 3j, root 2j and minus root 2j. So you will get the intersection point on the imaginary axis. This is another rule. Okay. Now, angle of arrival and angle of departure. Angle of arrival. Arrival means, now if you go to bus stand, railway station or airport, everywhere on the timetable, arrival time, departure time is written. What does it mean? Arrival means it arrives at that station. Departure means it goes away from that station, anywhere. Now, that means the root locus departs from the pole because it leaves the pole, goes away from the pole, and it arrives at 0. So the angle of departure is associated with the pole and angle of arrival is always associated with a 0. Do you agree? Because it arrives to 0, so angle of arrival is associated with 0 and angle of departure is associated with the pole. In our problem, there is no 0. So there is no question of angle of arrival. We can calculate only angle of departure. So how many poles are there? 3 poles are there. One at 0, one at -1 and one at -2. So there are 3 angle of departures, one each for each pole. So the angle of departure or angle of arrival, there is a common formula. Formula remains same. It is sum of angle of zeros minus sum of angle of poles is equal to some odd multiple of 180 degrees. This 2q plus 1, q is an integer. It can take any value, 0, 1, 2, 3, 4, 5, 6, anything. If you put q is equal to 0 here, it will become 180. If you put q is equal to 1, it will become 3 into 180. If that is 3 pi. If you make q is equal to 2, it will become 5 pi. Q is equal to 3, 7 pi. Q is equal to 4, 9 pi, like that. That means it can take any odd value in terms of pi. That is 108 pi, 2, 3 pi, 5 pi, 7 pi, 9 pi, like that. So don't bother much about that. You have to end up in only 1 pi only, that is 180 degrees only. Now you have to calculate. There are 3 poles, so 3 angle of departures you have to calculate. So first one for pole at 0. See, this is our pole at 0. I will connect this pole with other pole and other zeros. Here there are no zeros, so I am forced to connect with the poles only. So I will connect this pole to this pole. I will connect this pole to this pole and measure the angle. So this angle is 180 degrees. This angle is also 180 degrees. And I am calculating angle of departure. Angle of departure has to be added with the poles only. So sum of angle of zeros. There are no zeros, so 0. Minus is there, so minus I will take common. Angle of departure for this pole is phi 0 or phi d 0. Angle of departure for this pole with -1 is 180, and for -2 is also 180. So 180 plus 180 is 360. That means it is 0 only. So it will finally becomes minus phi d, because 360 means one full rotation. You have to just remove that. So that means phi d 0 is minus phi d 0 is 180. That means phi d 0 is minus 180. See, minus 180 means this way, plus 180 means this way. Both are same. That means what you get the idea from that is this pole will go along 180 degrees line. 180 degrees line, whether it will be 180 degree line means this way only. So it will go towards left. That means root locus starting at 0 will go towards left. See, I will continue this class and I will finish this problem and leave the class. Afterwards, I am not going to give the break today because it will lose. I will lose the continuity. Is it okay? Have you understood?
Yes, sir.
Yes, sir.
Have you getting this point? This problem is solved in similar problem is solved in number of books. Just interpretation may be different. Just read those things. Because as I said, unless you solve henceforth in unit number 3 and unit number 4, unless on your own you solve the problems, calculation is very simple. It is simple arithmetic. Even a primary school student also can do the calculation once I tell them the rules. But the thing is interpretation that requires the practice. Remember that and think accordingly. So it is minus 180. Minus 180 means 180 minus 180 and plus 180 is same. So it is, that means you will get the indication that pole at 0, whatever pole at 0 is there, its root locus will go towards left. That idea you got it. So it is same as this case. Pole here at 0 is going towards left. Is it clear? Then second pole. Second pole is at -1. So for pole at -1, let us call it as angle of departure as phi d -1. So here this pole is in between the two poles. So this pole you connect with this pole, this angle is 0 only. Whereas this pole, if you connect with this pole, this angle is 180 degrees. Okay. So that means sum of angle of zeros is 0 minus this angle is 0. This angle is 180 plus angle of departure of this pole with itself. Just like that. That is phi d -1. I have to add it with the poles only, because I am calculating departure. So this phi d is associated with the departure angle, and phi a it is with the arrival angle if it is zeros are there. That type of problem we'll see later. Should be equal to 180. So this 180 is minus 180. If it goes on the other side, it will become plus 180. So plus 180 plus 180 is 360, that is 0. So phi d is either you take it as minus 0 or plus 0. Both are same. So zero angle means, that means zero angle when you get, when it is coming towards this. That means the second pole, which is at minus 1, its root locus will not go towards left, but it will come towards right. Just like this problem. Just like this problem. It is not going this way. It is coming this way. Is it clear? So that means what? The root locus starting here is coming this way. Root locus starting here, coming this way. They meet here. So there is a breakaway point between 0 and minus 1. This idea also you will get by this. So because the root locus on the 0 pole is going towards left and root locus on minus 1 pole is coming towards right. One is coming to going left, another is coming towards right, means they have to meet somewhere. And that meeting point is the breakaway point. And what is that breakaway point? We have already calculated two breakaway points. One is minus 0.43. Which one is feasible now? Tell me. Which one is feasible now? Minus 0.43 or minus 1.577. You have to search for a point which is lying between minus 1 and 0. So only possibility is minus 0.423. So minus 0.423 is only possible. Now we have to still calculate. Another may be also possible. That we'll see. So whether this is possible or not, that we'll see by calculating the third angle of departure. The third angle of departure is for pole at a minus 2. So pole at a minus 2, that is phi d minus 2. Angle of zeros are 0 minus. If you join this line with this line, that is angle is 0. Join this line with this line, angle is 0. Both the angles are 0. When both the angles are 0, add phi d to that, which is equal to 180 degrees. So phi d minus 2 is minus 180 degrees or plus 180 degrees. So that means plus 180 degree means it is going towards left. 0 means coming towards right. 180 means going towards left. So that means the root locus at minus 2 will go towards left. It will not come towards minus 1. It is going to minus infinity. That means the other breakaway point which you have calculated, minus 1.577, that is not feasible. So only breakaway point feasible is 0.43. Minus 0.43. Minus is not printed here. Everything is minus only. Now all the 8 rules are completed. Now the major job is there. So for remember, if this problem comes for 10 marks, for 8 rules calculation, 8 marks will be there. 1 plus 1 plus 1, or sometimes it will be 6. For plot only will carry 4 to whatever marks. I can give this problem for 15 marks also. If I give this for 15 marks, I will keep 8 marks for calculation, 7 marks for the 5 marks for the plot, and 2 marks for interpretation. Like that. That means these rules calculation can anybody do. In that case, you will get only 8 marks out of 15. This plot is very, very important. Now, just see here how to plot that. Listen carefully, very interesting. So, first, I will draw the axis. This is real axis sigma. This is j omega axis. It is called as S plane and never referred as real and imaginary axis. There is a reason for that you will come to know in the next chapter. This is called as sigma j omega axis only, not x axis, y axis, not real and imaginary axis. It is called as sigma j omega axis because it is in the Cartesian coordinate. The Cartesian coordinate means you have to plot any point by two coordinates, x coordinate and y coordinate. X coordinate is real coordinate here and y coordinate is imaginary coordinate. A real imaginary plane, it will be plotted in polar plot. It will be in polar coordinates, not in Cartesian coordinates. So that's why the difference. So this is called as sigma axis, this is called as j omega axis. Whereas in the next chapter, it will be called as real axis and imaginary axis because it is in the polar coordinates. This is how it has been differentiated. Now the root locus, one root locus will start at 0 as per the rule number 1. One root locus will start at -1 and one root locus will start at -2. Correct? At that time, the value of k is 0. K is 0 here also, here also, here also. Now, as the value of k goes on increasing, see the angle of departure for this pole, it has to move towards left. It starts moving slowly towards left. So the arrow mark is on the left side. Whereas the pole at -1, its angle of departure is towards right. So it will start moving towards right. So arrow mark is towards right. When k goes on increasing, finally both of them will meet here at k is equal to s is equal to 0.43. I don't know value of k at that time. I'm not bothered also. When it is 0.43, -43, it is minus point because this is 0 and this is -1. In between that, -0.43 point is there, they will meet each other. Whereas the pole at -2 will go towards left. It will go towards left up to infinity because there is 0 at infinity. So the breakaway, this will not approach this way. It will not approach this way, and that -1577, 1.577 point is useless or redundant point. It is actually, it will give you the minimum value of k actually. So we are not bothered about that. So the root locus which is starting at -2 will go to -infinity this way straight, whereas the root locus starting at 0, it will come towards left, and root locus starting at -1 will come towards right, and they meet each other. Once they meet each other, what will happen? Okay. One, in the sketch, I have done a mistake. I have not drawn the asymptotes. I have forgot that. We have asymptote in the rule number 4. Correct? Rule number 4. Yes. In the rule number 4, starting point of the asymptote is -1, and there are 3 asymptotes: 60, 180, 300. So the starting point of the asymptote is -1. Here I have forgot to draw. There is one line like this. There is one line like this, 60 degrees in counterclockwise direction. One line like this, 180 degrees in a counterclockwise direction. Another line like this, 300 degrees in a counterclockwise direction, which is -60. So remember this thing, asymptote means it is a line drawn to a tangent to a curve which will never meet that curve. So 180 line is straight line. It is going parallel to whole of this curve. You can see. See, the curve is not above that line. They are parallel, which you can't see because you are in the 2 dimension. If you see the 3rd dimension, if you see the top view of this, which is never drawn, these 2 lines are parallel. Asymptotes is parallel to this line. It is behind this or ahead of this. Whereas the 60-degree line is going parallel to this curve, and 300-degree line is going parallel to this curve. So one curve goes parallel to that, one curve goes parallel to 300, one curve goes parallel to 60. Up to where it will cut the imaginary axis. Where it will cut the imaginary axis, that is what we have got, that by using the Raoult stability criteria, we got the cutting point at plus root 2j. This vertical distance is root 2j, and this vertical distance is minus root 2j. So it will cut there. At cutting point, k value is 6. Afterwards, this root locus will go to infinity. This way infinity, it will go to this way infinity because there are no zeros. The zeros are always in the infinity. So from this curve, what you can predict, you can see. When k goes on, k is equal to 0, there is one pole at the origin. That means it is on the j omega axis, the system is limitedly stable. As the value of k goes on increasing, one root locus will start moving towards left. That means the poles are moving towards left, means the system becomes more and more stable. And this pole is coming towards light, and this root locus will go towards minus infinity away. So all the roots will go towards left hand side only. That means system becomes more and more and more and more stable as the value of k goes on increasing. But after some time, when the root locus meet each other at the breakaway point, that is minus 0.43, afterwards this root locus will go there, but these two root locus will move in the imaginary plane. When the imaginary plane means the poles will have both real part as well as imaginary part. When the poles roots have both real and imaginary part means they are complex conjugate. When they are complex conjugate, the response will be oscillatory. So that means up to 0.43, the root locus is on the real axis and hence it is overdamped. And at 0.43, it becomes critically damped, but because two roots meet each other. And afterwards, the response becomes oscillatory, hence the system becomes underdamped. But when k is equal to 6, the two roots will come on the imaginary axis once again. Complex conjugate roots will come on the imaginary axis. That means if the roots come on the imaginary axis, system becomes limitedly stable. So system becomes limitedly stable at k is equal to 0 also and k is equal to 6 also. And after 6, when k increases beyond 6, this root will go towards right. And this root is also go towards right. That means if the root comes to the right, system becomes unstable because the roots have to be on the left hand side only to become the stable. So when k value becomes greater than 6, it becomes unstable. When k value is 0 or 6, it is limitedly stable, and between 0 and 6, it is stable. So when the system, so detailed analysis you have carried out, you have not only carried out that at what value of k the behavior of the system is important. If the value of k is below greater than 0, less than 6, system is stable. If the value of k is greater than 6, system is unstable. And up to some point it is overdamped, then it becomes critically damped, then it becomes underdamped. That means zeta, as k goes on increasing, zeta goes on decreasing. Zeta is equal to zeta will become equal to 1 when they will meet each other, that is at 0.43. Is it clear? Is this interpretation clear to you? You can answer that, otherwise I will repeat. Yes, any questions? So here what you have to do is you have to find out these 8 rules and calculations. Afterwards do this plot, and below that you have to interpolate this plot. The interpretation of the plot means if the k value is 0 and 6, the system is limitedly stable. If the k value is greater than 0 but less than 6, it is stable. And if the k value is greater than 6, it becomes unstable. These 3 lines you have to write, and for that 1 or 2 marks are assigned. Is it clear? If there are no questions, I will stop here. Any questions are there? No questions? This is the simplest of the problem. And this same problem with slightly different values is asked number of times in the lot many question papers of both VTU as well as GIT. So here I will take the break now, and next week, see, on Wednesday you have a test. Monday, Tuesday, Wednesday, you have a test, so you will not be attending Wednesday's class. Thursday's class is very important. Make sure all of you attend that. Thursday at same time between 12 to 2. So here I will stop recording and stop presenting.